Okay, Year 12, I'm going to go over some of the questions in this exercise because some students have been emailing me with questions. Now, I know I've done the solutions earlier, but some people are having trouble. I've done the solutions and put it on the web page, but some students are having trouble deciding, do I add, do I subtract? And the only way you know about whether you're going to add or subtract is if you draw the diagram. So the questions I've been asked are from 9 onwards. So I'm going to do these 4 here. And sorry, the wrong ones. Here we go. I'm going to do these 4 down to here. And I'm also going to do 17 because I had a question about that and I think you'll have a bit of trouble with that one. So I know these solutions are in the web, but as a PDF, but let's have a go at these. So remember, the first thing you have to do is you have to draw the curves and you have to find the points of intersection by solving simultaneously, and then you can decide whether or not you're going to add or subtract these areas. So if we look at the first one, and we see we've got to draw y equals x cubed and this line. So let's draw them. And I would normally use a ruler, but I don't have access to that. I know I can get one up here, but that's only for measuring. So I'm going to do a freehand diagram. And I'll do y equals x cubed in blue. There's y equals x cubed. And I'm going to do, let's go purple for the y equals minus 3x plus 4. Now, we know that this is a straight line. It has a y-intercept of 4, so I'll just go about there. A gradient of 3, which makes it reasonably steep, and I need to find the x-intercept. So it's going to, let's just say, draw it down like that. So they're my 2 curves. Here's my y equals x cubed. And here's my y equals minus 3x plus 4. Now at that point, remember from graphing your linear, I can just change the sign of that and divide by that, which will be negative 4 divided by negative 3. So it's going to be 4 over 3 because the negatives will cancel. So 1 1/3. Now I need to find this point of intersection. So I'll solve them simultaneously. So x cubed equals minus 3x plus 4. Now, this is a lot harder, and you really shouldn't be asked to solve a cubic, but I'm just going to go x cubed minus 3x. Now, you won't be asked to do this. You will not be asked to solve this. It's a cubic. You only have to solve quadratic equations. But you can work this out. X outside of x squared minus 3. Oh, sorry. That's a plus 3 equals 4. Now, I know that 0 won't work. There's only one solution. And the only way you can find this is just by guess and check. So you won't be asked to do this. Don't worry. But the number that will make that work is x equals 1. There are other ways. You can just try guess and check. You can try and throw a few numbers in there. But we've got the number 1. So you won't be required to do that solving simultaneously. You won't be asked to solve a cubic. But let's go back to finding the area. Now there are 2 areas here. We've got the area here under the blue curve, which is this area. We've got the area here under the purple curve. So there are 2 of them. So we have to find the area under each of them and add it together. And because we've got the point of intersection, and we also know that this is a point 0, it's a really easy thing to set up. So what do? The area, so this is a sum. We're going to add those two areas. So it's the area, and let's do the purple bit first, from 4 on 3 to 1 of, under this purple curve, minus 3x plus 4 dx. And then I have to do the bit under the blue. So I'm going to add from 1 to 0, because it's from 1 to 0, it's this bit here under the x cubed curve. Now, I integrate this first bit, and again with the integration, I've got add 1 to the power minus 3x squared over 2 plus 4x. And that's between 4 on 3 and 1. Plus, I've got this bit, which is add 1 to the power, x to the 4 over 4, between 1 and 0. So that's the area. The first one's the area under the purple curve, purple line between 4 on 3 and 1, and the other one's underneath the cubic between 1 and 0. So now if I just do that, I get minus 3, and this is the most important one, 4 on 3 squared over 2 plus 4 times 4 on 3, and I'm going to put that in parentheses, minus 3 times 1 squared on 2 plus 4 times 1 plus 1 to the power of 4 on 4 minus 0 to the power of 4 on 4. And then you grab your calculator and you pump it all in, and you get, what's that, 5/12 of a unit squared. So that was a sum, all right? And that was question, what was it? 9. So let's now have a look at 10. So here we go again. Find the area enclosed by these two curves. All right. So again, we have to draw them. And if we can draw them, we're away. So what's the first one? X minus 2 all squared. Now you should be good at this. X minus 2 all squared. And again, I'll do it in blue. It's going to go, that's a double root at 2. And if I square that, it's going to go through 4. Like if I just look at the last number here, this number here, because that's going to be the constant. I know that's going to be squared. So I'm going to get y equals x squared minus 2 times 2 minus 4x plus 4. So that's a y-intercept. So this is a parabola. It comes down like that. Keeps going. Let's do the next one in purple again. Now, what is it? Y equals minus x minus 4 all squared. So again, it's a double root, but this time it's going through 4. It's a positive parabola. It will go through 16. I'm not going to mark it up there because it's going to be so, it's going to be hard to mark it up here because it's going to be right up there. But I know that it's going to come, and guess what? I know that the gradient is the same. It has the same gradient. How do I know that? Because if I were to expand both of these, they would have 1 in front of the x squared. So it comes down here and turns around. Now, we're referring to the area between these two. So I have to again find the point of intersection. Now this time you should be able to find it because we've got two parabolas together. So here we go. Let's just indicate the area that we've got to do. So I'm going to draw a red line down there. I've got to find that x value. And remember, on the left-hand side is the blue area. And that's just under the blue curve. Where on the right-hand side, I have the purple area, which is under the purple curve. There are two sets. As soon as I find that point of intersection. So let's find that point of intersection. So what have we got? X minus 2 all squared equals x minus 4 all squared. Now, I can expand these. So I'm going to get x squared minus 4x plus 4. And here I get x squared minus 8x plus 16. Now, the x, if I minus x squared from both sides, I've got minus 4x, so I'll bring this 8x over. So I'll add 8x and I'll get 4x. And I'll take that 4 over the other side and I'll get 12. And then I divide by the 4 and I get 3. And this point here is 3. So now I can set up my area. And my area is the integral between 2 and 3. Let's look back under the blue curve. And the blue curve was x minus 2. X minus 2 dx. And then I've got to get the area under the purple curve, all right? Okay, under the purple curve. And that's from 3 to 4 under the purple curve. So plus, because I've got two areas, 3 to 4, oh sorry, and there's a square there, x minus 4 all squared dx. Now, I've already expanded them, so I could, and I know in my solutions that I did expand them, all right? But I'm going to do it because we are better than that. We can do this because they're linear. Because they're linear, I'm going to get x minus 2, add 1 to the power, divide by the new power, and also divide by the derivative of the function. But because it's linear, because there's 1, I only have to divide by 3. So that one was really easy. And so will this one be. So it's going to be x minus 4, add 1 to the power, divide by the power, also divide by the derivative of what's inside, and it's 1, so that's pretty easy. And I've got 4 and 3. Excellent. So this is, remember, this is the area under the blue bit. This is the area of the blue bit. And this is the area of the purple section. All right? Okay, so here we go. Substitute our values in, and we get 3 minus 2 cubed over 3 minus, this is going to be cool, 2 minus 2 cubed, which is going to be 0, over 3. So that's going to be nice and easy. And the purple bit, 4 minus 4 cubed over 3 minus 3 minus 4 cubed over 3. All right, so I'm going to get, 3 minus 2 is a third, is 1, 1 cubed is a third, so I get a third. Plus, I'm going to keep this in the parentheses here, I'm going to get 0 minus, 3 minus 4 is negative 1, negative 1 cubed is negative 1, negative 1 on 3. So I'm going to get a third plus negative, negative, another third, which is 2/3 of a unit squared because we're finding area. Righto. Now, let's go to the next one. And this is a good one because it's the area between two curves. They don't give us anything. We're going to have to solve some stuff simultaneously. And here we go. So it's y equals x cubed and y equals x squared. So again, you've got to be able to draw them, and you really do need to know which one goes over the top. So again, purple and blue. So we'll do the blue one first, and we'll do the cubic. So here's the cubic. And here's the parabola. Now, this is hard because you've got to know which one goes over the top. And the parabola goes over the top. I've drawn it wrong in my solutions. So if you check it, so here's y equals x squared, and here's y equals x cubed. Now, it doesn't matter if you got them the wrong way around, because when you do the subtraction, you'll get a negative area. So let's, so here's the area we're trying to find between the two of them. So essentially, I'm finding the area underneath the x squared. I'm going to draw it down here. We're finding the whole area there underneath the x squared, subtracting this bit here, which is underneath the x cubed, and what we get left with is a bit between. So let's set it up. Well, first we have to find the point of intersection. So x cubed equals x squared. Don't be tempted to divide by x squared. All right, so take that x cubed, x squared over. Now it's equal to 0. Now I can factorise out the x squared, and I get x minus 1. And I know x equals 0. Well, we can see that. That's there. And x equals 1, which is this point here. So I'm going to set up my area now. Area equals, and because they're the same parameters, I put them in the same equation. I can write them separately, but because I've got the same parameters. So it's from 0 to 1, and what's on top? X squared minus x cubed dx. Okay, so integrate both of those. So this is the blue bit, the x cubed. That's the blue curve. And this is the purple curve. It's on top. All right, so I get x cubed on 3 minus x to the 4 on 4 between 1 and 0. So this is going to pump out nice and easily. So I get 1 cubed on 3 minus 1 to the 4 on 4 minus, and I'm not going to go through with that, it's just 0 minus 0, so it's just 0, which gives me 1/3 minus 1/4. You whack that into your calculator, it's going to be 4/12 minus 3/12, which gives us 1/12 of a unit squared. Righto, so now let's do the next one. Question 11. Is it 11? We're up to 12. It's 12. So what have we got here? Y equals x squared. And look at this, they've been tricky. They've written this one as x equals y squared. Now remember, we're going around the x-axis, so we're going to write them as y equals. So here we go. Let's draw them first. So y equals x squared. I will do that bad boy in blue. So there's y equals x squared. And in purple, I'm going to do x equals y squared. That's just a parabola here. And that's x equals y squared. And the area we need to find is the area here. Now, if you're having trouble working out whether you're going to do a subtraction, if the area is, or an addition, if the area is like this, two parts, and you've got two curves, and you add. Where if the area is between the two, you just subtract. And we're going to have to do the purple one minus the blue one. All right, so first of all, you have to find the point of intersection. So the point of intersection. Now, I'm going to write this one as y equals root x. So now I can equate them, and I get x squared equals root x. Now, if I square both sides, I get x to the 4 equals x. If I bring that over, x to the 4 minus x equals 0. Take the x out, and I get x cubed minus 1. That means x equals 0 and x cubed equals 1, which means x equals the cube root of 1, which is 1. And now that makes sense. Look up here. Here we go. There's the 1 and there's the 0. So I've got my parameters. So now it's easy, and I know the purple one's on top. And remember, we're going to use that one. So we're going to use x to a half. So here we go. Let's set it up. Our area equals the integral from 0 to 1 of root x minus x squared dx. Okay, so that's the integral. That's a terrible one. I must not be happy with that. That's the integral of x to the half minus x squared dx. Righto. So x to the half, add 1 to the power, 3 on 2, and then divide by that. Well, if I divide by 3 on 2, I'm multiplying by 2 on 3. So 2x to the 3 on 2 thirds. Minus, add 1 to the power, x cubed, and divide by that 3. Between 1 and 0. So this is going to be really easy because 1 to the power of anything is itself. So I get 2 times 1 to the power of 3 on 2 over 3 minus 1 cubed on 3. And I'm not going to write this up. 0 to the power of anything is 0, except to the power of 0. But they're, 3 on 2 on 3. And I'm going to get 0 divided by 3. So this is all going to come to 0 when I substitute the 0 in there. Which means I'm going to get 2 thirds minus 1 third. No, that's awful. Come on. Which is a third. So let's recap. If you're finding an area with two parts, you add. And it's pretty easy to see when you've got two parts. They're under separate curves and the x-axis. But when you're finding the area between two curves and it's completely enclosed between those two curves, you subtract, and you subtract the top one minus the bottom one. We're going around the x-axis. Now, don't worry if you mess it up, because you'll get a negative answer, and you just have to understand you've subtracted them the wrong way round. All right? So here, with this question, if you hadn't gotten the right way around, if you've gone x cubed minus x squared, your answer here would have been negative a 12th, and you would have had to realise, oh, maybe I've got them the wrong way around. So now I want to do question 17. which is the area between sine x and cos x. All right, sine x and cos x. So this is a hard one. 17. Let's find a bit of room. Here we go. So y 17, and I'm going to graph them. So again, purple and blue. So I'll do blue for sine x, and there's sine x. I'm going to do purple for cos x. So it's not really neat. This should come further down, but I'm going to be happy with that because I'm not going to get it perfect. So the area I need is this area here between these two. And you can see that sine x is above. So here's y equals sine x. And here's y equals cos x. Now, to solve these simultaneously, well, you know when sine x equals cos x, it's when it's 45 degrees. Well, you should know that. So you go back and you look at your little triangle and you go, when it's pi on 4, I get 1 root 2, and sine x and cos x are exactly the same. Down here, so that one's going to be really easy. This point here is pi on 4. And this point, they're both negative. Well, when will that happen? When will they both be negative? Well, we know all stations to central. Well, it's not here because it's not here because sine's going to be positive there, and it's not here because cos is going to be positive there. They're all positive here, so it must be here. And what's this one? Pi plus theta. Oh, so pi plus the acute angle, so pi plus pi on 4, because that's the acute angle that gives us, that's it there. Well, 1 pi plus pi on 4, well, that's 4 pi's on 4 plus 1 pi on 4 will give me 5 pi on 4. So this is 5 pi on 4. A whole pi plus 1 pi on 4. So now I've got it. I set up my area. My area equals the integral from pi on 4 to 5 pi on 4. What's on top? Sine x minus cos x dx. Okay. Well, now it should be rather simple. So the integral of sine x, and remember this little trick, sine, cos, negative, negative, differentiate down this way, integrate up this way. So the integral of sine, negative cos. So I get negative cos x minus the integral of cos, or the integral of cos is sine, so minus cos x minus sine x between pi on 4 and 5 pi on 4. Okay. So I get. Now, here's a hint. You can take the negative out of that, if that makes it, and then you'll have a negative out the front and you'll have cos x plus sine x. I'm going to leave it in just so you can see that it works. Would have made it easy, but it might make the calculation easier. So in here, I get negative cos 5 pi on 4 minus sine 5 pi on 4 minus negative cos pi on 4 minus sine pi on 4. Now, before you start panicking, you already know that these two things will give you the same ratio. They're going to give you 1 on root 2, and pi on 4 will be positive, and 5 pi on 4 will be negative because it's in that quadrant. So Here we go. It's just 1 on root 2. So what do I get? Minus, now cos 5 pi on 4, they're both negative, negative 1 on root 2, minus sine pi on 4, negative 1 on root 2, minus, now cos pi on 4 is positive. Yeah, this is, you can see it here. Here they are on the curve. This is 1 on root 2. And this value here, over here, is negative 1 on root 2. Okay. So, cos pi on 4, well, there's a negative there, and it's cos pi on 4 is 1 on root 2. Sine pi on 4, 1 on root 2. Okay. These will just change to a positive, so I'm going to get plus 1 on root 2, plus 1 on root 2. I'm going to get 2 on root 2. And over here, I've got minus 1 on root 2. Look over here, I've got minus 1 on root 2, minus another 1 on root 2. So I'm going to have minus 2 on root 2. Oh, great. A negative and a negative is a positive. So I'm going to get 4 on root 2. Because that's going to become, this bit here is going to become plus. And 2 plus 2 is 4. And the denominator stays the same. Now, I need to rationalise. So I'm going to multiply top and bottom by root 2, which is going to give me 4 on root 2 on 2. And wow, look at that. 2 goes into itself once, 2 goes into 4 twice. So my final answer is 2 root 2 units squared. Right, now let's recap. If you're finding 2 separate areas under and over the x-axis, you've got to add. If you're finding 2 bits, like the bit under the blue, the bit under the purple. Here again, the bit under, you can see, right, you're finding the bit under the blue, then you're finding the bit under the purple. But then here, you're finding the bit in between, them. So you do the one on top minus the one underneath. And it doesn't matter if it goes above and below the x-axis. These are all above, but it doesn't matter. Here again, the bit above it. And look at this one, this last one. It doesn't matter if sometimes it goes below the x-axis. It doesn't matter. You just go the one above minus the one below, and it'll pop out. Okay. If you have any more trouble, send me an email or come and see me early before class. Good luck.